Hello and welcome. Today we're going to continue working on our BASIC interpreter. BASIC here is for AppleSoft BASIC, which is a programming language from the 60s? Yeah, from the 60s. That was used in a bunch of computers back in the olden days. Looks something like this. We've got a little, in our little repo here, we've got test this guy, which is just a simple program written in BASIC that prints the Fibonacci sequence. So if I did, I'm in the wrong window. If we open this again, if I did BW basic test foo baz. This is kind of our reference. And this is just some random basic interpreter I found online. Then you see it just prints the numbers from 0 through 89, which is what this is supposed to do. It does up to 100. Or any number that is, yeah, it does up to 100. So if A is greater than 100, then we're going to end, otherwise we're going to print A. I did want to see, can I do that on a new line? Is that something I can do? It is not. Okay, so that does count as a separate instruction. Or not an instruction, but like an if everything needs to be on the same line, which is a little bit weird. But I think that's fine. I think if you were to want to do something else, you would put like I said 70 here is go to 70, and I don't think you need the then anymore. Missing space after line number 70. Okay, that's apparently required. Oh, probably also need to just have something here. Print die. Yeah, then it prints die. Okay. And if you put then here, it's still valid. Okay. So go to is just kind of a shorthand, I guess. But yeah, so right now we have, if I do main, let's actually go and say make and main on test foo baz, then we get this output, which is effectively lexing just the input. So you'll see if I pull up over here, we've got our line number here, which is 10, and then we've got ident let a equals 0 colon b equals 1, which is this heading here. Let a equals 0 colon b equals 1, and this just assigns two variables. Okay, and then we see that we have that for the entire thing. However, you'll notice that things like ident, or things that like let, are classified as identifiers right now. That's not correct. We have separate tokens for them, so let's go ahead and add that to our Lexer implementation. So if we look at Lexer, I'm going to zoom out a little bit. If we look at Lexer H, you'll see up here we have a token for let. And this doesn't have the full set of tokens, it just has the tokens that we need for this example. And then I think we'll add new ones as we go. But we're going to have a function that says like token kind, ident to token, takes in a const char star ident. And wait, we do have a concept of a token. I think we can just go straight to a token rather than returning like a kind. So it's going to return a token. And then what we'll do here, and actually we shouldn't even take a const anymore. We should say if so if we look at stir comp, there's stir case comp, which does ignoring case, and in basic, case doesn't matter. So we're gonna do stir in case comp. Do we need to do that? I mean, yeah, we might as well do stir n case comp. Why does e go to there? That's annoying. Yeah, so we'll do stir in case comp. It takes s1, which is gonna be ident, and then we'll say let. And I think we have nothing greater than like 5 in here. Yeah, we've got clear. I'm going to go under the assumption that this is the maximum length of tokens. And the reason that we do 5 here is because if you have like a really long identifier, we don't want to have to like check that against everything, I guess. Although it really doesn't matter. No, yeah, it doesn't matter. Stir case comp. If this is 0, then we're going to return token where kind is token or tk let, and that's it. It's let. I'm gonna say else if stir case comp ident. I guess we can just go down the list. Clear. This is 0. Then we're gonna return tk clear. And we could do this in a loop. I don't think it's actually worth doing it in a loop. And like have is it worth it? Yeah, we might as well. That implementation is fairly straightforward. So we can say const char star. Oh, we really can't just put it into a loop, can we? Oh, no, I guess we could do struct name and token kind token map is an array of these, and it looks like this. This is a C thing that you can do. Some other languages have this, but this is a structure defined inline right here, which means that we can't name it elsewhere, but we can kind of still use it. So then here we can say let goes to tk let, and so on. So we got clear, gets tk clear. What else do we have? We've got dim is tk dim. We've got def is tk def. Fn and go to fn go to. And I guess in reality we should make these all uppercase, just because that's kind of the convention we're going for in like the official, or in like the more standard aspect. So identifiers are not going to be matched here, and none of this stuff. Or I guess we have then and print. Easy align. Are you going to work? It's a little bit funky when it comes to doing that. Yeah. That is what I just did, isn't it? Yeah. Whatever. We'll do this by hand because it is kind of bothering me. Beautiful. Yeah, and this should actually even be aligned with these? Yeah. No. It's off by 1. Now they're aligned. Beautiful. Okay. So we have also this is equal. I'm honestly not even certain that this is how you do less than or greater than or equal. But that's fine. So then and print. Cool. Now we can loop through this. So we can say for size t, I equals 0, I is less than, and then how do we get the length of this? So we can say, define array length, takes in an array, and what the hell am I doing? And it returns size of array divide by size of array, but dereferenced. And so what this does, if I have enough parentheses, is it will take the size of the array, and this gives you the size in bytes, and then if you divide it by the size of the array, or by the size of a single element of the array, then you get the size of, or a number of items in the array. That was horribly explained, but that's okay. So say you have an array of integers. Say you've got 3 integers. So you've got 1, 2, 3. This is represented, I say integers. Let's say you've got an array of 3 16-bit integers, just because it's less to type. This is represented as 0, 1, 0, 2, and 0, 3 in like hexadecimal. Or that in hexadecimal. Ignoring Indianness. If you take the size of this array, you'll get 1, 2, 3, 4, 5, 6 bytes. And then if you take the size of just a single item, you'll get 2. Take the size of a single item, you get 2. So if we take the size of the full array, which is 6, and we divide by the size of a single array, 2, we get 3, which is the length of the array. And so we can do that here. Array len of array, and then plus I. This is unhappy because undeclared identifier array. That's fine. We can actually spell it out. We're not lazy programmers. We can actually spell it out all of the way because we're super not lazy. Token map. Great. And I suspect the compiler might even just unroll this loop, but that's fine. If token map at I, if stir case comp this to ident is 0, then we're going to return token map I at kind as a token. And this is dot name, like that. And then finally at the end, we can just return token tk ident and ident. And then down here, when we do actually get our identifier, before we do this construction, we can just do return, or I guess da append into out. We're going to append ident to token, where ident is ident. And then now if we run this, then we get let ident a equals number literal colon ident b. Great. We still have ident if. Did I not add if? I guess I didn't. And then the mild annoyance is that we now have to update this map too. But I don't actually know of a good way to avoid that in C. We could, using some macro magic. I think we could. I almost want to try it. So let's say we're going to use something called an X macro. I think there's a Wikipedia on it. Yeah. Which is define this list of list of something. They're not really variables, they're more constants. To be X applied to the values. And then whenever you want to do something with it. You're just defining X to do something different. I guess in this case they mean variables as in variable names. But yeah, so we can say define identifiers, or not even idents, but like text tokens. And this is going to be X applied to clear. Okay, you know what? We're going to just make all of these uppercase. It'll make everything here easier. So we can say clear. Then we can say let. And so these are going to be tokens that are specifically consist of text. So something that you can get from an identifier. Yeah, that's going to error for a minute, but that's fine. I'm just going to copy paste everything up there, and then we'll clean it up. So we get this. Then we do this. Then we do this. Then we do that. Great. So now this is our list of tokens. And actually we can even put that guy there. And then here we can remove them. So clear list that. Did I get def, fn, and go to? I did. Should we do that? And then we do that. And then here we can say define X to take in the name. And then all it does is say tk underscore hash name. And then we could say text tokens. And then we undefine X. Redefinition of if. Oh, I didn't remove that one. Missing comma between, yeah. So that's just because we need a comma here. So what this does, if you're not familiar with this pound syntax, is it takes two identifiers and concatenates them. I can CPP on, what is this file? Source lexer h. Yeah, so you'll see it takes what we wrote clear here, and it just prepends tk underscore, and then separates them with commas, like that. And we could even make it look a little bit pretty, I think, if we put a backslash or a new line here. No. Okay, I kind of thought that new line was copied in, but I guess not. But yeah, so now we have a nice way to define these tokens. Now let's see what we can do here. So this is going to be same kind of thing. We say define X to take in the token. And then this time it's going to do a hash token. And it's going to do tk underscore hash token. Like that. And so this part is the same as before. But this part will turn the token into a string literal. Or it'll turn whatever was passed into here into a string literal. So now we can say what is it? Text tokens? Is that what I called it? Text tokens. And then we can undef X. And it's good practice just to immediately undefine it, because you're not going to use it like this anywhere else, and then this way you won't have any like conflicts or anything. It does cause a mild issue if you have X, if you're using X as a macro or something for some reason, but generally you don't, because that's a bad macro name, so this is fine. But yeah, so now this, well, that's cool. I didn't know that this showed what it expands to. But if we look at the token map, you can see this is what it contains. Also, that reference to the first element is a little bit weird, I think. I don't know why it does that. It doesn't matter, but anyways. Yeah, so now we have this, which will automatically update whenever we introduce a new text token. So like if we look at the, hold on, let me pull out that reference. Yeah. If we look at this, you'll see we also have, so we got clear, dim, def, go to, go sub. We have go sub, which is not one that we have in this list. So we can say x go sub this, and then you'll notice if I add, if I do make this guy, and then we say echo go sub, or I guess not, wait, I'm in fish, not in bash, so p sub, then you'll notice we have a bunch of issues. That is actually an aspect because these all need to be updated now, which is fairly straightforward. It's just a little bit of a pain. Also, TK dim doesn't exist. Did I mess that one up? Oh, I didn't. Oh, it's called TK dim. Yeah, that it did mess up. Great. Bam, bam, bam. Sorry, I just got a message. And then finally we just added, you know, that's another thing we could add. Since we're just printing these tokens, we could do, I'm going to steal this X macro from here. We can just make this do this. We can say case, TK, or no, wait, not that. We do it here. It's a little bit of a weird way to do it, but it works actually quite well. We can say TK, or case, TK underscore hash hash token, printf, hash token, semicolon break. And then now we don't need most of this. And since it's just printing, that's fine. So that goes away. That one goes away. This one goes away. This one goes away. And we still have a bunch of issues, probably because we still have these. Boop. 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 Unexpected EOF. Yeah, but I don't know why it's error or why it's just spamming that, but that's fine. Yeah, so now we get the go sub, and we just only added it in this one location. And we can even do grep rn go sub, and it exists in one spot, so that's cool. Okay, so let's fix that issue that we just ran into, because that does not seem good. That might be an issue in main, actually. So Lex next line is, we don't actually have any, or I guess it's probably in the Lex or H that says, yeah, 1 means success, 0 means done, -1 means failure. So unexpected EOF, where was that? In here, unexpected EOF. So this one breaks. This one also just breaks. This one prints, let me just say like foo in front of it. Okay, so it is this one that breaks, which makes sense. Because we're just printing it and we're not returning it. Like that. Okay. Great. So now we get unexpected EOF and it stops. In function that's line 40. Missing braces around initializer. What the hell are you talking about? I definitely see a brace there. Or a bracket. Wait, let's add more parentheses. No. Can you tell me where it's trying to expand it? Line 56. Oh, it doesn't like this return, I think. Is that the issue? Or value ident. I suspect it's probably related to the value ident. Yeah. So maybe if we did this, it would be okay. Yeah. This is not the correct location for that error, but okay. That's fine. We figured it out. In fact, let's even just do value ident. Okay, so now we are lexing correctly. Honestly, this unexpected EOF is a little bit sad. Let's even make that a better error message. And also, I think I literally left the foo there. Yeah. Let's just say missing line number at. We don't have an at, but missing line number. Bam. And now if I did 69, then we're no longer missing it. Cool. Fantastic. Now what? Yeah, we finished that quite a bit earlier than I was expecting to. I don't know why I was expecting it to take long, but that's fine. Test foo baz or base. Baz or base? Not sure. So now I've got let ident equals that. Ident b equals 1. Okay. So now we need to store these instructions into something. So I'm thinking we just have a dynamic array. Yeah, we just have like a tokens, or not even tokens, a lines. Called lines. Type def struct, and this is gonna have const, not const, line, a token line. Yeah. Line or items. Wow, I'm not programming in C apparently. I don't know what language I'm trying to program in, but it's definitely not the one that I'm using. Size t items and count, or not items, count and capacity. I know what I'm doing. Is it called capacity? I'm implementing a structure with not this, but this guy. No. This guy. This thing. Capacity, items, and count. Okay. So also we're gonna grab this guy and we're gonna put it into I guess macros.h. And then now we can say include macros h. We can throw this guy in there, I guess. And if in def macros h, define macros h, and if like that. Okay, so now we have macros h, and then in here we can use the da append. While we're in lexer h, you actually don't depend on it, but lexer c depends on macros h. This guy can go away. This guy can also go away. We can throw him in here. Popchar's local. Array len can be moved. And yeah, that should be cool. So now if we go back to main, we can say, after we get an out, oh yeah, we just iterate it to print, that's fine. Then we can say lines, push, not, what the fuck? I do not know what language I'm trying to program in right now, but it is certainly not C. DA append into lines, and we're going to push out. Oh, and there's a couple of things that we need in here. So we need assert and standard lib, and I think that's it in macros. Okay, so it does the same thing now. Right? If I go back to main C, yeah, it does the same thing, except now we actually keep a total. So if I say print f size is lines count, and we put a new line here. Run this, we get size is 6, which is correct. So we get 10, 20, 30, 4, or I guess 1, 2, 3, 4, 5, 6 lines. Cool. Now I want to do just a quick check because at the moment, this code, if I did like 35 here, this is valid, but it should not be. So I just want to do, and since we are just appending to an array, I can literally just do if out, not out, but lines items at lines dot count -1 dot line is greater than or equal to out dot line. Then we're going to say fprintf to standard error. We're going to say invalid line number. Percent %lu is greater than or equal to %lu. And this will be, I guess we can say size t prev line is this. And if the previous line is greater than or equal to the current line, then we're going to say that the prev line is greater than or equal to out line. And then we can return 1. Bam. Ooh, we got a segfault. That's cool. Right, if we don't have a previous line, then it's not a concern. If lines count is not, or is, if it's not 0, then we can do this. And we can even just be greater than, because why not? Okay, so invalid line number 35 is greater than 30. Cool. And then I think at some point we'll have some sort of like special printing that'll print the current line number or something, but I think it's fine. Okay, so now this still works. Cool. I guess it's time for some like expression parsing, which I don't really know how to do. Like in the sense of like operator precedence and that kind of stuff. I actually just don't know how to do that off the top of my head. So I guess we're gonna have to look that up. That's fine. So we can say it's a little bit weird, I think, here because you only have very simple expressions. We've got a plus b, but I think you could say a plus b plus 1. If I did BW basic. Yeah, so you can just add more. What happens if I do times 2? That's valid. Okay. That's fine. Actually, before we even try to do expressions, let's just get this let to work. Or rather, let's parse the let. I do want to do parsing still, but we'll parse this expression. Or it's a little bit weird because this colon is supposed to separate expressions, or I guess not even expressions, but statements. It's supposed to separate these statements. So this is just kind of like an implicit let. If I did that, are you still okay? Yeah, I think that let is actually just optional here. Can I use let to reset a variable? I can. So let here is just ignored. That is kind of weird, but okay. I can work with that. So let's parse that line. Pun is not intended there, but if you like it, then enjoy it. Okay, I'm gonna remove all of this logging. So now it's just empty, mostly. And then we're gonna add a module, not a module, a file called parse h. So what is this gonna have? We need to contain some information about what? So we effectively need an AST. It's not quite as sophisticated as an AST, because it's not really a tree. It is a little bit, right? Like you've got expression trees. That's interesting actually. You really don't have trees. Like even an if statement doesn't have blocks or anything like that. It's only got goto. If we look at if expression, then statement, but not like a block or anything. You have a single statement. That's interesting. Does BW basic have a REPL? I don't remember. Yeah, so if I did 10, A equals 5. If A is less than 10, then A equals 10. Does that work? How do I run it? Go to 10. Or wait, no. Do you have like a help? That'd be really cool. BW basic help. Maybe a man. Maybe we just write a file. We already have a file. We already have a file called boo. I guess let's make a test bar baz. No, baz. Base. So 10 is A is 5. 20 is if A is less than 5, then A is 10. Then 30 is print A. If we run test bar baz, then we get 5. Or, okay, I meant 10 here. That's fine. Then we get 10. Okay, so we can do like actual statements there, but just a statement. We can't do like multiple statements or anything. So it is sort of a tree, because I think I could say like, then if A is less than 8, then A is 10. Is that a fair thing to do? Or I guess A is like 20. So that, okay, so it is a tree in that sense, that the right side of this if can contain another if. Although I don't really see why you would do that. I assume there's like an and. Maybe not. And. Numeric functions, string functions, type conversions, system interactions, Boolean operators. Yeah, there is and. I was just expecting it to highlight and. Okay, so yeah, there is and. So there's not really any point in chaining if statements, but you can, so we should support that. So let's support that. Right now, we're just going to support... I think all we're going to do right at this moment is to implement just like the let aspect. So what I want to have is a pub struct. This is not fucking Rust. Typedef struct AST. This is going to hold an AST kind. And this is going to be a kind and an AST value, which is a called value. And then we can have typedef enum AST kind. And this is going to have, what is this going to have? If we go look at the top, we've got flow control. I think just generally right now, I want if. We can even say if then. AK for AST kind. And I guess if we're being consistent with the others, we're doing all capital. Actually, instead of doing if then, I just want to say if. And then we can have, as part of the typedef struct, or not even struct, this is a union, AST value. We're going to have if, which we can't do like this. I guess we can say if is going to be a if typedef struct if, and then in here is where we're going to put our condition. So we're going to have AST, or we're going to have AST, and it's going to have to be a pointer so that it's indirect, and this is going to be the condition. But the problem is it's not even an AST, it is specifically an expression. Right, like you can't put like a let inside of here. It has to be an expression, which means that we should probably differentiate between the two. Although, is it really necessary to do so? I don't know that it is. Like yeah, we can differentiate between the two when we go to like actually parse it, but in terms of storage, I don't know that it's even necessary to differentiate. It might make the code a little bit simpler. Yeah, let's do that. So we'll have an AST statement, and we'll have an AST expression, and then we can also just have an union, which is an AST. Actually, we'll come back to that one. So this is they're both gonna hold. Expressions are just kind of weird, because it could just hold, like what is actually stored in an expression right now. An expression is a tree, but a statement isn't. You know what? No, okay. I think my brain works better with these just being a single thing, which is fine. So we can do that. This, right, it needs to be forward declared. Typedef struct AST is AST. And then you can be AST. Great. And you are that. So now, let's also do an include guard while I'm thinking about it. If and def parse h, then define parse h, then endef that. And then so this if, we have a condition, then we also have AST, what is this called? Statement. Yeah, that sounds good. Does it mention what the colon operator does? It's not really an operator. It's literally just a delimiter. Okay, it doesn't really seem to. What I'm going to end up doing for parsing is that each line parses into a list of ASTs and most of those ASTs are just going to be empty, purely because most of the time you're not going to put two statements on the same line. Like we have one statement, one statement, one statement, two statements, one statement. So we only have two lines in this thing that has two statements. So, okay, yeah, that'll be fine. And then this if has a condition, which points at, what the hell is this? I don't know what I just did. This if has a condition. If we go back to parse.h, the condition here is an AST, which is going to be this guy. And then the statement is going to point to this. Okay, cool. What else? What other kind of statements do we have? Just going down the list, I guess. We have let, which we can also define as being this. This one's a little bit interesting because we actually have a token. We don't even need to do this. We can say const char ident, which is going to be the identifier onto which we are assigning a value. And then we have a statement, which is going to be the right-hand side of this let. Okay. And then same thing here. This is also going to parse into a let because it doesn't end up mattering. Mattering. Is that a word? I think that is a word. It doesn't actually matter because this let is actually completely optional. I guess baz. Great. Cool. So now we have let. What else do we need? So we got if, then we need print, which is just going to take a statement. And honestly, this can even be expression to make it super obvious what it is. This one's going to be print, which is going to be a expression, and that's all it holds. Also, we need to update this, so this needs to be let for let, print for print. Great. What else? We have let, and go to. So go to. What? Oh, I copied the wrong thing. AK go to goot. Go to, which is gonna hold on to a line number, and that is it. Also, I don't have size T. Includes to def, and I guess this should actually probably be here. So everything here continues to work, which means it actually doesn't mean anything because we're not even using it. That's fine. If we go back to main and I say parse.c, include parse.h, and then we're going to say, well, actually in parse, now we need to define the functions that we're going to expose. I think all we're going to say is we have an AST, or a function that returns an AST, and this is going to be parse tokens. And what is this going to take? It's going to take, wait, we are in the header file. Good catch. I think it really just needs to take a line, or a token line. Which we put here. And this token line gives us the information, like the list of tokens. And then I think what we're going to do is we're going to say if what are we going to say? Just basically just read the tokens to parse a single expression. Or a single statement. No, you know what? We have parse expression, parse expr, and parse stmt. And that'll give you decent error reporting and all of that kind of thing. All of the somewhat useful aspect that we care about. And actually, on the topic of error reporting, these should probably return some sort of integer. I guess int. And this should return through a pointer. So AST. And I like to call this out. Okay. Now what? I guess now we can just implement this. So let's go back to parse C. And let's grab these definitions and implement them. So right now we'll just say to do this. Include macros H to do parse statement. I'm a little surprised that this doesn't... Oh, this doesn't exit. Definitely is supposed to. Yeah, okay, so this is, if we run this, nothing happens. That's because we're not calling this function. So now, I guess we don't even need to collect the lines in reality. We can go ahead and just parse them because they're never going to change. So now let's say, here, instead of this being lines, let's call this ASTs. And this could arguably be put into the parse file, but we can move that in just a bit. So if we get ASTs count, ASTO, we do need to keep track of the previous line. I think we literally just do this. We can say -1, I guess. Size t -1. If prev line is greater than 0, greater than or equal to 0. Now, you know, if it's greater than -1, then we do this. Prev line is that. Then we get all of that. This is no longer LU, it's LD. And then here we can say AST is 0 initialized. And then we can say AST. Wait, did I guess it's called parse expr. It takes the line and it needs the out, right, which is called AST. This line doesn't exist because it's also called out, which, let me rename this to be line. Like so. And then now we can say ASTs count here. And we can append and do ASTs, AST. Okay, now to do parse statement. Cool, so now, if I go to parse.c, we can do define, take token, and this is going to take the tokens. And what is it going to do? It's going to say, so it's a little bit weird because we aren't, I guess we're going left to right in the tokens. Oh, that's kind of weird. Because our tokens are in order. If we could pop off of the end or something, then that would be cool, but we can't. I guess what we really could just do is say size ti equals 0. And then say tokens at I++. The problem is then it's not updating the other calls to tokens. Which is a little bit sad. Like if we have a call after, or I guess not even parse expression, but parse statement. If we have a call to parse statement, like so say we're doing the semicolon or the colon separated values, the second call would need to do something with this tokens in order for that to work. So I'm thinking, how can we make this a little bit nicer to use? So we could take this by a pointer and then like effectively like unshift from the front. I think let's do that for now and we can change it later. So we can say define DA unshift. That's a bad name. That's from JavaScript. We're not doing that. Pop front takes tokens, or I guess array, and yeah, that's it. And says oh, this isn't even gonna be nice, is it? Yeah, this really isn't gonna be good. Because this will require us to remove the item, and just doing this in a macro especially is what makes it kind of bad. We need to remove the item and hold on to it somehow. And then we need to shift all the other elements. You know, this would be so much easier, actually, if we just reverse the order of the line. I think let's just go ahead and do that. So for size ti equals 0, I is less than what is it? AST's no, not even AST, it's line count plus I, line items at I. So line items gives you a token. Save this for a moment, then say this is line count minus I minus 1, and then this is going to be this guy becomes the temporary. Great. So this will just reverse the order of the tokens in the line. Just to confirm that, let's say for size ti is 0, I is less than line count plus I, print lex print token line items at I. Printf a new line. What's the type conflict? I see no type conflict. Here we're taking by pointer versus there we're taking by owned, or I guess copied. That's fine, that's unused, but that doesn't matter. There's a different issue here, which is that line needs to be passed by reference in main. Cool. So we get let ident a equals that. So that literally just didn't work. Yeah, how did that not work? I is, oh, this is supposed to be divided by 2. Let a equal 0, colon b equals 1. Great. Yeah, we don't need this anymore. I'm gonna keep this there for debug purposes. And then now, if we go to parse C, then we can say define, or we don't even need to say DA pop. Yeah, let's say define DA pop actually. And this is going to take the dynamic array. And all it's going to do is say DA at, and I guess really we need a bunch of parentheses around everything. Okay, so it takes the DA. Then we're going to index by DA items. And we do need this by pointer. No, we don't. This doesn't even need to be pointer. I'm going to make it a pointer because I think that makes a little more sense, actually. DA items minus minus. Yeah, I think that works. And then now we can say DA pop on tokens. And it's not items. Again, it is count. Subscriptive value is not an array, pointer, or vector. That is also correct. Which means that I don't need to dereference that there. Great. We do still need to wrap it with parentheses because C is bad. Okay. Great. Now, you can fuck off. And if I say lex print token t, then we should get the first token of every line, basically. Except for parse expr is not working, and this should be parse statement. So we got equal sign, which is not correct. Why do we get an equal sign? If I don't... Oh, it needs to be minus minus? Yeah. That equal sign is because C is a very unsafe language and I just did an out of bounds memory access. Well, out of bounds is relative, but certainly not the array I was trying to touch. Okay, that's fine. So now we have the first token, and with that we can actually switch on T kind. Okay, so if we get equal sign or parenthesis... Wait, are parentheses even valid? They are in certain contexts. But they can't, I don't know that they can be in an expression. Oh, it might, that might be how you call a function, actually. So we don't care about this or this, comma. What context is a comma allowed in? I guess there are contexts. Okay, we can keep a comma. Identifier is invalid, I think. No, wait, no. Identifier is totally valid. Never mind. So I'm going to basically put everything that is valid as a statement, as the first item in a statement, to the bottom. This isn't valid. This is debatable. Do we want to consider colon a statement? I'm going to say no. Number literal is not a statement, not a statement, not a statement, not a statement, not a statement. This one is a statement. This one is a statement. Plus is not. Dim is not. Maybe. Dim is a statement. Def and function, or def is, but function is not. So def where we go to if then is not, end is, print, and go sub r. And here I just want to say fprintf invalid or unexpected token. Unexpected token. This thing. And here we can say print lex print token. T. That. Okay. So if we get an identifier, or actually, let's do it that way. So we can group these. Like this. And then let and ident can actually be grouped together. Except before we do this, we need to say T is DA pop tokens. Because at that point, once we pop that identifier, then we have the same thing that we would have either way. So that's fine. Here we can say let L. Wow, this feels kind of wrong to just type the word let in C. So let is going to have ident, which is going to be what? T dot value dot ident. And then expression. So it's a little bit interesting because expressions, since they're so simple, we could just do like reverse Polish notation, or like do the what's it called, infix to prefix. Not a calculator, but the algorithm to do like 1 plus 2. You probably want JavaScript. 1 plus 2 plus 3 times 3. And convert to be like this, and then just calculate it that way. Or, not even infix to prefix, but like infix to postfix. Do you have a infix to postfix? That guy. Do this conversion. Which gives us just an easier way to evaluate. And then we don't actually have to put any like parsing logic in here. This does get a little bit funky when you try to add like function calls and stuff into it, but I'm not even sure if those are allowed. If I go to here and I say print a plus 2, is this okay? Not foo, but bar. So that is okay. But if I did, because if we look, we've got some function calls in here. If I did cosine, can I put cosine there? Okay. Can I put cosine here? I can. So I have, it's not impossible. I've got a calculator that does basically that exact thing. It says AST, but it's hardly an AST. Wow, this is kind of bad. I wrote this a long time ago. Yeah, 2 years ago already. But basically, it takes the infix notation, which is like the conventional way of doing mathematics, and it converts it into the postfix notation, which is fairly simple to do. But the reason I bring this up is because we could then, instead of having, if we go back to parse.h, we could, rather than having AST, or I guess rather than having print hold an AST as the expression, we could just have it be a sequence of tokens that we then convert into reverse Polish notation, or postfix notation. And I think that would be fine. In fact, I see no issue with it. So let's go ahead and start working with it that way. Yeah, I think actually we just replace all expressions like that. So this is an expression, or it's still cut condition. Let's even, to get super fancy with that, type def struct expression. In fact, we even can have token items. We can make this a dynamic array. Size t, that's a semicolon. Count capacity. Like that. And that's not how you do that. And then now, this can say, hey, we're looking for an expression here. Hey, we're looking for an expression here, and here. Yeah, okay, that sounds cool. Now, here, we're basically going to say, expression E is something that's just some zero initialized stuff. And then while tokens items, or I guess we can even create a DA peak, which does everything except for that. DA peak on tokens. While the token kind is not, or it's actually a little bit weird because peak could give you out of bounds. So you need to say tokens dot count is greater than 0, or I guess arrow, and the last kind is not token kind or tk underscore colon, right? No, not quite. Because there's a list of things that you could be here, or that are effectively like terminating. So like no. So I'm thinking like then is also terminating for an expression, but that's not valid in this context. So we can just kind of walk for this here, and I think that's cool. We're going to say DA append into E, where we append token. Or I guess we can even say T is DA pop tokens. And then we actually also need to save the ident. So const char star. Ident here is const char, I think. Ident is T value ident. And then expression here is E. Okay, yeah. So now, what are we doing here? So we get the expression, we save the identifier, then we're gonna walk while we have tokens, and the next token, or the current token, is not a colon. Then we're just gonna read this into this array, and then we save that as L. Okay, so that worked. Unused variable L, that is true. We need to say return AST. No, not even that. Sorry, it's star. Or it's out. Kind is a k let, and out value dot let is L. Actually, that's probably not even necessary. It is in fact necessary. So we do this. We could even inline this really. Really? That doesn't work? That's fine. So now we can do, or I actually do want to inline that. like that. Bam. Cool. So now we can do this. Control reaches end of non-void function. That's true. We can just assume that if we get down here, then we're going to have failed. This also needs to return 1. And then like here, this is actually really weird. Do I have a panic? I don't. This actually, this is really an assert. Unreachable, invalid token kind. Which in C, it's actually not unreachable because these are just integers and you can just like add 1. But like it shouldn't happen unless you have like memory corruption. That's really the only case. And if we just assert there, then we have an issue, except we did assert there. Oh shit, wait, no. This really should just be like a default, because default, we are gonna fall through. There, that's better. Okay, if we go back to main, I kind of want to print it, but we don't have a way to print things. Yeah, we don't really have a way to print anything, so I'm not gonna bother with that right now, but that's fine. So let's go to, I guess let's go parse if statements. So bam, we're gonna do the same thing. We don't care about the identifier. We do care about the expression. Then we're gonna say take while TK, while the token is not TK then, which isn't quite right, because we also need to say DA peak is not goto, because that is valid syntax. So we can do this. I don't really know how to format that. I don't think there's any good way to format it, but that's fine. Actually, no, I do want this. I don't know. It looks like shit, but that's fine. Who cares? So we get if. And then this is condition. Or we can even just call it cond, because we're lazy programmers. Then this becomes if, where we have condition is cond, and then expression, no, that's not what it's called. Statement is going to be parse statement on tokens into statement. So AST statement is going to be this. And if this is not 0, then that means that we failed, and we can just return 1. And then here we can say statement. And this does need to be a pointer. That is true. Little bit annoying, but it is true. So we can just malloc size of statement. This is why we're lazy. STMT. Spelling is way too difficult to bother. So now we are allocating the size, parsing the structure, or parsing the statement, and then we are returning an if. And then now, finally, let's do print, or not even finally. Actually, before we do print, let's do end, because this one should be fairly straightforward. It's going to be return. No, it's going to be out. Kind is aka end. Aka end. Implicit conversion from token kind. What? Oh, okay. Yeah, we do have a statement called aka end, which doesn't have a value. I almost want to have like an empty, but I don't know that it actually even matters. So yeah, that's fine. We'll say out kind is aka end. Great. Now here for printing, it's basically the same as let, except we don't have any sort of condition. And statement is not what it is. It's probably called expression. Print. Or print here. Yeah, it's expression. Say expression. Expression. Or E, because we're super streamlined. If we get a colon, or we hit the end of the line, then we're done. And we're reading into E, like so. Field designator expression, right, this is a print. Like that. So now we're parsing, mostly. So this is going to be, that is bad. This is going to be, I just want to do a bunch of to-do, go sub. To do go to do def, dim, clear, and then none of these are valid, so we can do that. Unexpected token, go to then. Where? Line 57. Well, I mean, wait. Oh, to do, go to. You are exiting. Why are you... How does this get printed after that? Well, okay, I mean, I guess I know how it gets printed after that. That's because of line buffering. But why do we have unexpected token then? Oh, we, under the if, we never actually consume that token, which means the statement is empty. Or, does it? That's fine. DA pop tokens. Yeah, okay, so now we just have the to-do on go-to, which is fine, because we're not implementing that right now. However, that is, I think, going to call it for today. So let's push what we have here. I can remove, or I'm just not going to commit that test. It's not even finished lexing. It's just like more lexing and start parsing. So we can push that. All of this can be found in this repository here. Bam. But yeah, that's gonna be it for today. Thank you everybody who was watching, and I will see you next time.